mutations are really kind of the final frontier when it comes to managing cancer over the long haul. Mutations basically imply to a person's particular DNA. So DNA is what makes every part of our bodies up, right? Um, and every person has mutations in their DNA that allow cell damage. So, for example, the aging process is because of cell damage. Most cancers are caused by a damage to the DNA because once a cell knows that it's damaged in a normal person, a healthy person's body, the cell knows to commit suicide. And that's known as apoptosis. It's called programmed cell death. Programmed cell death happens in a healthy cell because it knows that there's something wrong. It doesn't need to replicate. It doesn't need to divide and create a lot more of itself. One of the prime mutations that most every cancer has is what's called P53. P53 is the tumor suppressor gene. And basically, most patients that have cancer have a damaged P53 gene. So people that have cancer most often have a gene that says, I don't know when I'm supposed to die. I'm going to keep on replicating and I'm going to keep on developing more cells, creating these tumors that eventually potentially lead to death. And P53 is one of the millions of types of different mutations that we're identifying today. So you've heard of the BRCA1 and 2 gene. People have that, that predisposes them to having breast cancer or ovarian cancer over their lifetime. We've identified the CHEK1 and CHEK2 gene mutation that does the same thing. You also have PIK3CA, which is one of the most common mutations found in breast cancer patients. Then you have the mTOR mutation. The list goes on and on and on, and you can really get lost in the alphabet soup of mutations. But the fact is, it can also be an Achilles heel from a treatment perspective. So if you look at patients that have a pretty generic mutation-less cancer that's fed by estrogen, my cancer, it's kind of a one-trick pony. So that's why I've experienced a really good response to my first-line therapy, which is just a hormone blocker and a bone drug. I've been without evidence of disease for about 30 months. So I'm very fortunate that I have a lot fewer mutations that allow my cancer to outthink the drugs. To the opposite of that, my best friend is also stage 4. She also has metastatic breast cancer. And she on paper looks identical to me. So if you look at it, we had bone mets, we had estrogen receptor fed, progesterone fed, HER2 negative metastatic breast cancer with metastases to bone. Start looking a little bit deeper and you realize, as Lisa's going through it and these drugs are failing her, she's not failing the drugs, there's a difference, the drugs are failing her, you find that she has mutations. She has at least 3 different mutations that they've identified that allows her cancer, when it's deprived of estrogen, to find a new way to grow. So basically you're looking at these different pathways that the cancer can evolve into and say, if I can't have estrogen to grow, I'm going to find a different way to continue to grow because cancer is very adaptable. So back to the final frontier about mutations is that there's a number of new drugs on the market and even in clinical trials that address these particular mutations and allow them to stop that mutation from affecting cancer growth. So what they do is they kind of approach it from a 3 or 4 prong approach where they're looking at, I'm going to give you a drug to turn off that mutation. They give you a drug to also address the estrogen, also to address whatever other concerns you have as far as HER2 or the location of metastases, for example, of the bones. That's kind of the way to personalize and precision medicine a certain person's treatment plan. And I know I'm going a little bit long on this, but it's really important. I had a cancer twin, Joe, somebody that was diagnosed the same exact day that I was with metastatic breast cancer, same exact met locations, same exact treatment plan, same exact personality of cancer. She died on September the 9th of last year. We started the same exact drug regimen. We experienced a completely different response to therapy. She developed metastases to liver, lung, eventually brain, and that's what killed her. Although on paper we were identical, she had, I guarantee you, a wide array of mutations that allowed her cancer to grow despite therapy. So if you really want to personalize medicine and create an environment where people can get a better response out of treatment, not just in guesswork, mutations are really the way to approach that.